contents which we are going to discuss. The first content is link between technology and physics. And the second content which we are going to discuss is fundamental forces in nature. These are the two contents we will discuss. Let us start the discussion. The first is, just 1 minute, yeah, here. The first is, what is the link between the technology and what physics principle is used for that technology? Okay, that is the first content. And first point is steam engine. This is one technology, and this technology of steam engine was based on the laws of thermodynamics. We know no, during 18th century this steam engine was developed, okay, during industrial revolution. Okay, during those days the laws of thermodynamics was used for the development of steam engine. The second technology, nuclear reactor. Nuclear reactor is based on controlled nuclear fission. Okay, this is physics principle. Based on the physics principle, nuclear reactor is actually, this technology is actually developed. Controlled nuclear fission is the principle. See, we know the difference between fission and fusion. Okay, in the previous lesson I have actually explained about this one. The relationship between fission and fusion I have explained in the previous lesson. Okay, and the third one, radio and television technology. Radio and television technology were developed based on the principle of generation, propagation and detection of electromagnetic waves. Okay, based on electromagnetic waves principle, the radio and television technology was developed. Okay, generation, propagation, detection of this wave, electromagnetic wave. Okay, and the fourth one, the computer technology. See, this is very famous now. We know that computer technology was developed based on digital logic. Okay, so digital logic, no, they are used in these circuits. Okay, they are used in circuits. They are used in gates. Okay, just 1 minute, guys. Yeah, they are used in circuits and gates. Okay, boards are there, no? Boards. Okay, in circuit boards they are used. Okay, in gates they are used digital logic. Okay, binary logic it is. Okay, binary values it will be having. Okay, binary values it will be having, and they will be using gates like NAND gate. Just 1 minute, I'll write here. They will be using gates like NAND gate, and they will be using gates like OR gate, AND gate. Gates are there. Okay, see, digital logic is nothing but it is actually used in electronic circuit boards, and it is also used in gates, and they take binary values. Okay, you understand this much, it's enough. Okay, digital logic, based on digital logic principle, computer technology was developed. The next is lasers. See, in the previous lesson I have actually explained about lasers. Okay, see, I explained now about masers, as well as I explained about laser, how lasers are produced and how masers are produced. In the previous lesson I have explained. Based on that technology only, laser technology was developed. Okay, what is that principle? Amplification of light by stimulated emission of radiation. Amplification of light by stimulated emission of radiation, the lasers are produced. Okay, that means narrow beam of light will be produced. So that is the fifth one. And when it comes to sixth one, production of ultra high magnetic field. How it is done? By using superconductivity principle of physics. By using superconductivity principle of physics, production of high magnitude field is, this technology is developed. Okay, these are 6 technology which we have discussed in this slide, and in the next slide we will be discussing 7th technology. See, in the 7th technology, rocket propulsion. This is one technology, and this just 1 minute, guys. Yeah, here, rocket propulsion. See, rocket propulsion is one technology which is based on Newton's laws of motion. We know Newton's laws of motion. Newton's laws of motion deals with the motion and force acting on that motion. Okay, motion and force acting on that motion is dealt in Newton's laws of motion, and based on this principle, the rocket propulsion is developed. And the 8th technology, electric generator. This also we have discussed in the previous lesson. See, electric generators are developed based on the principle of electromagnetic induction given by Faraday. We know no electromagnetic induction. Motive force, electromotive force is actually produced in this electromagnetic induction. This electromotive force is responsible for the generation of electric generator. Okay, induction cooking is there. Induction motors are there. Okay, all these are developed using Faraday's laws of electromagnetic induction. Okay, briefly I have explained in previous lessons also. Okay, so let us actually move on to the ninth technology, hydroelectric power. Hydroelectric power is developed based on the principle of conversion of gravitational potential energy into electrical energy. Conversion of gravitational potential energy into electrical energy. Okay, based on this principle, hydroelectric power is developed. The 10th one is aeroplane. Okay, see, this is very important. Okay, aeroplane based on Bernoulli's principles in fluid dynamics. Okay, I will explain this one. Wait, see, to explain this one, what we can do is see aeroplane. How will the aeroplane fly? You tell me. See, we will take the wings. Because of wings only, it is actually moving upward. Aeroplane. The wings will be designed in this way. Okay, the wings of aeroplane. Okay, it will be in this direction. It will be in this shape. The wings of aeroplane. Based on Bernoulli's principle, it will actually work. Aeroplane. Let us consider this as one wing, and when the aeroplane is moving forward, what will happen means air will come, no, air will come and it will take this path. Air will take this path one. Okay, this is called as upward stream. Okay, this is upper stream line. It is upper path, and another is this is another path. Okay, this is a lower streamline. This is upper streamline, and the below line is lower streamline. Upper streamline will actually this air is there, no, upper streamline air. It will actually pass above the blade of aeroplane, but lower streamline will pass from below, and the shape of the wing is like this. Okay, it is curved upside. It will go slope like this, but downside it is not that much curved. Okay, it is little bit flat. This is the reason why the aeroplane will fly. What will happen means, if this condition is happening, what will happen means here velocity will be maximum. Okay, upside no, it will be the velocity will be maximum. Okay, high velocity will be there. Up, that means upper streamline high velocity will be there, and this lower streamline low velocity will be there here. Okay, that means low velocity will be there in lower streamline. What will happen, whenever velocity increases, the pressure decreases, and whenever velocity decreases, the pressure increases, and this increase in pressure downwards is responsible for upward lift of aeroplane. This is what is known as Bernoulli principle. Okay, see, also we can observe this upper streamline is there, no, it will actually take the longer distance. It will take longer distance as compared to the lower part. Okay, lower streamline is there, no, as compared to lower streamline, the upper streamline will take long distance. Okay, that is the reason the velocity is higher in upper streamline. Whenever the velocity is high, the pressure will become less, and downwards whenever the velocity is low, the pressure will become high. Whenever this pressure will become high downwards, that means downside of the aeroplane wing, this is responsible for upward lift of the aeroplane. Okay, based on this principle, the aeroplane is developed. Bernoulli's principle it is called as. Okay, this principle is based on velocity and pressure. Whenever there is difference in pressure, that is actually responsible for upward lifting of objects. Based on that one, they have developed the aeroplane. Okay, very nice and simple explanation, no? Okay, very bombard explanation. Now let us move on to the next one, particle accelerator. Okay, I have told, no, in the previous videos I have told particle accelerator. Okay, it is based on motion of charged particle in electromagnetic field. Okay, see, whenever there is motion of charged particle, that is what is known as particle accelerator. Okay, in the previous video, no, I have taken one ion Okay, ion source, I have taken one ion source, okay, that will actually go in the spiral direction and it will hit one target. Okay, cyclotron example I have given in previous lesson. Okay, that is that phenomena is what they are telling here. Okay, that means whenever there is motion of charged part, that means the principle based on motion of charged particle in electromagnetic field is responsible for the particle accelerator technology. Okay, that is 11th one. Now let's move on to the 12th one. See, when it comes to sonar, what is sonar? Do you know? I think you people might have heard about this one, sonar. You see, sonars are nothing but they are used to measure the depth of sea. The depth of sea is measured using sonars. Okay, and here sonars uses reflection of ultrasonic waves. Okay, reflection of ultrasonic wave technology, that means this principle, reflection of ultrasonic principle is used in sonar technology. Okay, why they are used means to actually measure the depth of sea. They will send ultrasonic waves beneath the sea. Okay, so that based on the technology of ultrasonic waves, how the waves are going and coming back, based on that technology they will actually measure the depth of sea, sonars. Okay, very nice technology what they have developed. The next is 13th one, optical fibers. Okay, see, in optical fibers we know that a total internal reflection of light will happen. See, what is total internal reflection of light? Any idea you people are having? Total internal reflection of light, I'll write here. See, total internal reflection of light means the complete reflection of ray of light, the complete reflection of ray of light within a medium from surrounding surface. The complete reflection of ray of light within a medium from surrounding surfaces back into that medium. That is what is known as total internal reflection. Okay, I will give an example. Okay, you consider this as uh, here one light source is there. Okay, one light source. Okay, LS we will call it as light source, and from this light source light is emitting in this direction. Okay, one ray is going here. Okay, and let us consider this as water medium, and let us consider this as air medium. Ray will go like this. Another ray is there, it will just 1 minute guys, like this it will come here, another ray, and it will get refracted. Okay, refracted, it will get refracted here, not reflected, it is refracted. Refraction will take place, and this is normal. So refraction will take place, and when the rays goes like this, it will come back. Okay, see, this condition is there, one condition is there, based on that condition the rays are going to reflect back. Okay, you may ask, sir, what is the condition where the rays will come back into the medium? Okay, that condition is whenever the angle of incidence is greater than critical angle. Okay, whenever this angle of incidence is greater than critical angle, this kind of reflection will take place within that medium only. That is what is known as total internal reflection. Getting? I'll repeat it again. Whenever the angle of incidence is greater than critical angle, total internal reflection takes place. Okay, and whenever it is not greater, the rays are refracted into other mediums. Okay, see, this is a big this is quite a big phenomena which we will study in optics. Okay, just for your understanding, you just have this much picture. Okay, that is enough. Okay, so let us actually move on to the 14th one. Just 1 minute guys. Here, 14th one. What 14th technology is there? The 14th technology is non-reflecting coating. It is based on thin film optical interference. Optical film interference also is a big theory. Optical interference is also a big theory which you will study in optics. Okay, so thin film optical interference is physics principle which is used to develop a technology like non-reflecting coating. Okay, the next one, electron microscope. See, in the electron microscope we use a wave nature of electrons. And the 16th is photocells. Photocells are based on the principle of photoelectric effect. See, we know no photoelectric effect. Whenever light falls on metal, so electrically charged particles are released from metal. That is what is known as photoelectric effect. This one we have already studied in previous lessons. Okay, now let us actually move on to the 17th one. Fusion test reactor. Tokamak, it is also called as fusion test reactor. It is based on principle of magnetic confinement of plasma. It is based on the principle of magnetic confinement of plasma. Just 1 minute, guys. The application of tokamak. What is the application of tokamak? If you ask me, I will tell. See, the application of tokamak is they are used in controlled. They are used in controlled thermonuclear fusion power. They are used in, or we can tell they are used to produce controlled thermonuclear fusion power. Okay, that is the use of tokamak. Okay, that's it, guys. Let's move on to the next one. Okay, here giant meter wave radio telescope, GMRT, very famous. Okay, see, they use technology like detection of cosmic radio waves. Okay, based on detection of cosmic radio wave technology, the giant meter wave radio telescope is developed. Okay, and let's move on to the next one. Bose-Einstein condensate. This is one technology. I will explain what is this. See, Bose-Einstein condensate is nothing but it is a state of matter. I'll write here. It is a state of matter which is actually formed. This is a state of matter which is actually formed when gas of boson, when gas of bosons at very low density are cooled to temperature close to absolute zero. That is what is known as Bose-Einstein condensate. I'll repeat it again. See, Bose-Einstein condensate is a state of matter which is formed when gas of boson at very low density are cooled to temperature very close to absolute zero. That is what is known as Bose-Einstein condensate. Okay, see, this is one technology which is based on the principle like trapping and cooling of atoms by laser beams and magnetic field. Okay, this is physics technology. This technology used to develop the technology like Bose-Einstein condensate. Okay, you may ask, sir, what are these boson? You have written boson, no, sir. What is this boson? See, in subatomic world, there are two categories of particle, two broad categories of particle. Okay, one is fermion, and another is boson. Subatomic world. Okay, in subatomic world, these two particles are very important: fermions and bosons. Okay, and that's it, guys. This completes the link between technology and physics. Okay, here it completes. Now let's move on to the second content of this video: fundamental forces in nature. See, if you ask me what are the fundamental forces in nature, there are four major forces. They are, one is gravitational force, one is electromagnetic force, one is strong nuclear force, and fourth is weak nuclear force. These are the four major forces in nature. Let us discuss one by one. Okay, first one, let us take first one, gravitational force. See, we know that no gravitational equation we have, no, F is equal to G into m1 m2 divided by r square, gravitation. Okay, based on this this formula, the gravitational force can be explained. Okay, see, gravitational force is due to mutual attraction between any two objects. Okay, m1 m2 is the mass of those objects. The gravitational attraction between any two objects, there will be gravitational attraction between any two objects, it seems. Okay, and let m1 and m2 be their respective masses. It occurs by the virtue of their masses. Okay, that is the reason we have actually multiplied here m1 m2. It occurs by the virtue of masses of body. Okay, the third one, it is a universal force and it follows a inverse square law. You may ask, sir, what is this inverse square law? We know no, the equation is there. Okay, I by d square. See, inverse law is nothing but let us actually tell this I as a radiation intensity. I is radiation intensity and d is distance. So gravitational forces will follow inverse square law. Okay, given by this equation, I inversely proportional to square of distance, and they are universal. See, gravitational force are universal forces. Okay, the same gravitation applies on Earth also. The same gravitation will apply on Moon also. Acceleration due to gravity is different on Moon. Okay, acceleration due to gravity is different on Earth. Earth and Moon, it is different acceleration due to gravity, but gravity is same. Okay, gravitational law is universal. Okay, that point you have to keep in mind. The next is it governs the motion of celestial bodies in universe. Definitely no, because of gravitation only these planets are moving around sun. Planets are moving, no, they are moving around sun because of gravitational force. And also the satellites around the planet, like moon around Earth. Okay, why moon is revolving around Earth? Because of gravitational force. That is what they are telling here. It governs the motion of celestial bodies in universe. Celestial bodies means the universal bodies. That means in universe bodies are there, no, Earth, solar system. They are called as celestial bodies. Okay, the next. The formation and evolution of stars, galaxies, galactic clusters are due to gravitational attraction. Okay, see, gravitational force will actually explain a complete evolution of these stars, galaxies, and all. Based on gravitational force only, everything is actually going in their own paths. Okay, that means they will explain the evolution and the formation of stars, galaxies, and all. Gravitational force are very important to explain these things. Okay, that's it, guys. Let's move on to the next slide. So in this slide, they have given the equation F is equal to gravitational constant G m1 m2 by r square. But they say like this: the magnitude of force F, this one, the magnitude of force exerted by a particle of mass m1 on another particle m2 at a distance r is given by this equation, gravitational force. Okay, so you may ask, sir, what is the value of G here? We know the value of G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is the value of G, gravitational constant. Okay, that you have to remember. Okay, that's it, guys. Let's move on to the next slide. So in the next slide, second force, which is that second force? Electromagnetic force. See, when it comes to electromagnetic force, they are force due to interaction between charged particle Q1, Q2. Okay, they are the forces due to mutual interaction between charged particle, not bodies. Here it is particles, charged particles. Okay, so they tell that when charge are at rest, then force between them is electrostatic because they are in rest. If they are in motion, it is electrodynamic, but they are in rest. That is the reason they are telling that electrostatic, and it obeys inverse square law. Same thing, I proportional to inversely proportional to d square. It obeys inverse square law. Okay, see, only electromagnetic forces and gravitational forces will obey inverse square law. Nuclear forces will not obey inverse square law. This point you have to keep in mind. Okay. The next point. It is enormously strong. The strength of this electromagnetic force, no, it is very much strong as compared to gravitational force. Okay. 10 to the power of 36 times it is greater, it seems. When it comes to strength, the strength of this electromagnetic force is greater than gravitational force by 10 to the power of 36 times. Okay. And next point, in general, electric and magnetic effect are inseparable. Okay, that is what is known as electromagnetic force. In electromagnetic force, electric and magnetic fields are inseparable. Okay, the next one. Charge in motion produces magnetic effect and give rise to magnetic force on moving charge. Okay, some charge is there that is in motion, it is going, and this motion and this charge in motion will produce magnetic effect and it will give rise to magnetic force on the moving charge according to electromagnetic force. The next one, they give this one force in electromagnetic force is given by this one. See, this is known as Coulomb's constant. 1 by 4 pi epsilon naught. This is Coulomb constant. Okay. See, in the previous gravitational force, what we actually did, F is equal to G into m1 m2 by r square we did, no? Okay, in gravitational, but here it is not masses, it is q1 q2 charges and r square. Instead of G, here it is Coulomb constant. Okay, 4 pi epsilon naught. This is the equation. Okay, it is like this: the magnitude of electrostatic force F between two static point charges Q1 and Q2 separated by distance r is given by this one, Coulomb's law. Okay, and this is Coulomb constant, already we have told, and the value is 9 into 10 to the power of 9 Newton meter square per Coulomb square. Okay, and epsilon naught value, you have to remember this value, 8.85 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Okay, this is the value of epsilon naught. Okay, the next one, strong nuclear force. See, we know that now strong nuclear force, here protons are there, neutrons are there. Okay, this is one nucleus, that is just one minute guys, where it went, here. Okay, protons, neutrons are there. Okay, electrons will be like this, no? Just 1 minute. Electrons will be surrounding like this, no? So within this one, protons and neutrons are there, no, within nucleus. So strong nuclear forces are of three types. Protons and neutrons are there, no? So it is between force between neutron and neutron, force between proton, or it may be the force between neutron and proton. They are known as strong nuclear force. See, the force that bind the neutron and proton together in nucleus is called as strong nuclear force. Here it is there, no? Proton, this is neutron. Let us consider this is neutron, this is considered this is proton. Because of the binding of neutron and proton within the nucleus, the force that bind the proton and neutron within the nucleus is called as strong nuclear force. Very important. Okay, the next one. Just 1 minute. I'll see if I want to explain something extra. Just 1 minute. I'll see. No. Let's move on next. Here. So slide number 27. Just 1 minute, guys. Yeah, slide number 27. The strong nuclear force is the strongest of all forces. It is about 100 times stronger than electromagnetic force itself. This is the strongest force of all the forces mentioned. 4 forces we mentioned, no? In that 4 forces, this is the strongest force. Okay, and it is charge independent. It is not charge dependent. It is charge independent, because strong nuclear force is within nucleus, no? Proton and neutron. It is not coming out of nucleus. Okay, so within nucleus means protons and neutrons will be there. That is the reason it is charge independent. Okay, the next. The range is very small, 10 to the power of minus 15 meter. 10 to the power of minus 15 meter is the range of the strong nuclear force. Okay. The next, fourth one, weak nuclear force. See, weak nuclear forces are the force that appear only between elementary particles of short lifetime, which are involved in a nuclear process such as beta decay of nucleus. Okay, I will repeat it again. These are the forces that appear only between elementary particles of short lifetimes, which are involved in nuclear process like beta decay of nucleus. You may ask, sir, what is this beta decay? See, what happens now in beta decay, I'll write here. In beta decay, beta rays are emitted. Okay, whenever beta decay happens, whenever beta decay happens, beta rays are emitted from atomic nucleus. Okay, beta rays are emitted from atomic nucleus. Okay, the protons are converted into neutrons and vice versa. Neutrons can be converted into protons. Okay, see, whenever the protons are converted into neutrons, that is called as beta plus decay. And whenever the neutron converted into proton, that is called as beta minus decay. Okay, the protons in nucleus is transformed into neutron, and neutron in nucleus is transformed into proton. That is what is known as beta decay. Okay, it is a radioactive decay, beta decay. Okay, that's it, guys. The next point. It is not as weak as gravitation, but much weaker than electromagnetic force and strong nuclear force. Okay, strength wise they are telling. The next one, the range of weak nuclear force is 10 to the power of minus 16. See, strength is different, range is different. You should not confuse between strength and range. Range is 10 to the power of minus 16 here. Okay, in previously strong nuclear force, the range is 10 to the power of minus 15, but here it is minus 16. Range, I am not talking about strength, I am talking about range. Okay, the next point. See, if you want to compare the strength, not range, I am talking here about strength. If you want to compare the strength of the strength of the fundamental forces, this is Fg means gravitational force, Fw means weak nuclear force, electromagnetic force, E means electromagnetic force. Okay, E means electromagnetic force and N means strong nuclear force. See, these forces are in this relation. One means infinity. Just 1 minute, guys. One is nothing but infinity, infinite. Okay, and these are in this relation. Gravitational is very less, and weak nuclear force have strength 10 to the power of 26. Electromagnetic force have strength 10 to the power of 37. The strong nuclear forces have strength 10 to the power of 39. Okay, this is the equation which you have to remember. Okay, the next. See, these fundamental forces are there now. They arise due to exchange of field particles. Very important, these field particles. You may ask, sir, what are the field particles when it comes to gravitational force? The name of the field particles are graviton. Whenever we talk about electromagnetic force, the field particles are photon. Whenever we talk about strong nuclear force, the field particles are pi meson. And whenever we talk about that means weak nuclear force, the field particles are vector boson. Okay, vector boson. See, W plus or minus we have written. See, plus or minus, W plus or minus is, it may have either positive or negative electric charge. That is the reason I have written plus or minus. It may have either positive or negative electric charge. And Z0 indicates it is electrically neutral. W plus or minus Z0. Positive or negative charge, and Z0 is electrically neutral. Vector boson, weak nuclear forces. Okay, so this is what is there. That's it, guys. These were some of the explanation when it comes to lesson number